Okay, exercise number 21 on page 206. It's asking to determine whether this subset is a subspace of the space of continuous functions. Okay, so when you see C negative infinity infinity, this is the space of all continuous functions. Now, any continuous function, polynomial functions, any of those functions that you study in calculus that are continuous, okay? There's no gaps, no holes, right? The graph is pretty nice. It might have a spike, but no discontinuity, no jumps, no gaps. And functions that are defined from negative infinity to positive infinity. So that space is a vector space. Okay, what is the sum? What are the vectors in there? The vectors are the functions. What is the sum? The sum is just a regular sum of functions. Take two functions in the atom. The scalar multiplication, when you multiply c times the function, is just the function, the expression for the function times c. So it's pretty simple. Now what we want to show here is that a particular subset of that, we want to show whether it is a subspace or not. And the particular subset in this case is a set of functions f, okay, such that f is in the space of continuous function, and they obey this property that is described in exercise 21, okay, the set of odd functions. What is an odd function? Odd function means that if I plug a number into x, here, if I put negative x into the function, then that is the same as the negative of the function at x. In other words, I don't know if you remember what an odd function is, but the easiest way to understand odd function is that if you plug a negative number inside, or if you have a negative sign inside the function, you can actually pull the sign out. Okay, those are called odd functions. In case you're curious to know, okay, what will be an example of an odd function? Here's an example: f of x equals to x cubed. That's an odd function. Why? Because if I plug, for example, negative 2 in there, it will be negative 2 cubed. Negative 2 cubed is negative 8. So this is negative 8. Look what happens if I put negative of f2. Well, that's negative 8 as well. See? So it behaves like, well, it is an odd function because it looks like you can pull the negative sign out. Okay? Another example of odd function would be sine function. F of x equals to sine x. Well, it turns out that, for example, if you do f of x, f of negative x, that's sine of x, negative x. Sine of negative x is the same as negative sine of x. So you can see that this is negative of f of x. Okay, those are odd functions. Now this has nothing to do with proving that this is a subspace. It's just to illustrate for you the meaning of odd functions. Okay, let's go back here to the exercise. So let's show that this space, this set of odd functions, is a subspace. Well, all we need to do is to show two things. If I pick two vectors in there, two functions in there, and if I add them, then the sum is still in W. Okay, so let's pick any two vectors in W. Okay, here's one, F and G. Okay, because they're in W, it means that they are odd. Okay? It means that f of negative x equals to negative of f of x, and also g of negative x is negative g of x. That's because they are in W. And what we need to do is to compute the sum f plus g, is this thing in W? How do we show? Well, let's compute the sum. What is f plus g applied at negative x? Well, sum of functions, if you remember from college algebra, is just the f applied at x plus g applied, I'm sorry, it should be negative x, right? F applied to the input here, that's negative x, plus g applied to the input, negative x. Now, f and g are odd functions, so I can pull the negative sign out from them. They're odd functions. G of x, okay? All right, let's see now if this is the same as negative of f plus g of x. Well, let's see. What is f plus g of x? That's f of x plus g of x. And then just distribute the negative sign. It's negative f minus g of x. See, they're the same. So therefore, this is equal to this. So the conclusion is that f plus g, the sum, is in W. Now let's look at the scalar, okay? Scalar multiplication. If I take a scalar and multiply by a function, let's take f. Is this still in W? Let's check. First I do c of f of negative x, and then see what that is, and then I take c, take negative, right? So let me erase it. Oh, actually I could put negative of cf of x. Okay, so let's compute the top and let's compute the bottom and see if they're the same. If they're the same, then this is equal to this, and therefore cx is an odd, cf is an odd function, therefore it's in W. So this is cf let's put here parentheses. This means c times f of negative x. That's the definition of that from college algebra, right? Cf is c times f of x. In this case, negative x. Now f is an odd function, so I can pull the negative sign out. So this becomes negative c f of x. Okay, the bottom here, negative, inside will be c times f of x. Well, that's just c f of x. Yeah, see, they're the same. So cf is in W. Conclusion, W is a subspace of the original vector space, space of continuous functions.